everybody. As we delve more and more into using some of the clicky clicks, we need to also understand what the clicky clicks do. So now that we're going to be dealing with water flowing downstream, or down topography, if you would, across a field, we need to understand just exactly how all those tins work. This again will pay off for you as you try to leverage your knowledge of 3 years or 2 years or 1 year or however many years you work at this into something transferable to many different parts of engineering. And so I give you these statements for determining what would be called the down face or fall line, or as we like to call it, the direction that your putt breaks in sky golf. The first statement is this: the cross product, the cross or the vector product of any two non-parallel vectors in a plane defines the normal. The second statement: the cross product of the normal and the gravity vector, aka down, defines the iso elevation or a topo line direction. So it shows you along a face of a tin, it shows you the direction that would be the topo line, any topo line in that triangle of the tin, or any plane. And finally, the cross product of a topo line vector and a normal vector typically defines the down face or fall line direction. There is a calculator app for this. It's worth learning. However, until we are established in the fact that you can get on a computer and not play sky golf, we'll continue to use Wolfram Alpha. At the point where we can't do that anymore, we have established that it's not possible to sit at a computer and not do other stuff. We will go back to the antiquated calculators, and we'll still use the calculators. So here is how you input a vector. In most mathematical programs, it goes in as a list. And so you'll start to determine that depending on the program you're in, the list is either going to be stacked up or stacked across. The command in Mathematica is cross. I'm just going to show you here, cross. I think it's a bracket, probably wrong, and then open squiggly line. I'm just going to put a vector that's 1, 1, 1, close the squiggly line. The squiggly lines annotate lists just like they do in your calculator. And then in this case, I'm just going to go ahead and put up a vector that is -1, 1, -1. -1, -1, -1. Close that and close the bracket and hit equal. I'm sorry, close the hard bracket. Now you'll see Wolfram Alpha will take an input that doesn't look like this, but this is actually probably one of the more correct ones in Mathematica, if it indeed takes it. And so you're going to go down here. You notice it knew what it was, and it calculated the cross product. And so in this program, you've got to write down -2, 0, 2 on a side sheet of paper. On a lot of other programs, you can just feed it to the next problem. So the cross product of these two vectors is -2, 0, 0. So you can now go here and change this right away. -2, 0, 2. And then you're going to multiply that by the gravity vector, which is 0, 0, and -1. That's pretty much the direction of the gravity vector. And you'll see we're going to be using something called a normalized vector or a unit vector a lot. And so when we just want a direction, just like we do in views and AutoCAD, that's what we use. Hit an equals button here. Right, remembering -2, 0, 2. Because that, in fact, was the cross product of two vectors in the plane, so that was the normal. We're going to need that again. -2, 0, 2. As I write this down, -2, 0, 2 is the normal. What we get next is going to be the topo line. And so when I hit that button there, the topo line vector is 0, comma, minus 2, comma, 0. Now there's no and what you're going to see here in this face, it's going to look 0, comma, minus 2, comma, 0, which tells you the direction of the topo line. I think this face might be a little bit odd as we look at it later. So 0, comma, minus 2, comma, 0. And so now what we're going to do is we're going to multiply these two together. You notice this is how it comes in. I'm going to now multiply the result. So minus 2, comma, 0, comma, 2 times 0, comma, minus 2, comma, 0. Here, go back up to here, 0, comma, minus 2, comma, 0. Alright, so, and we'll see what we get. So, the result here, when it's normalized, gives you the direction of the down face. So this is the down face vector. We'll talk about how to normalize that. And we probably can go ahead and just take it and show you get the normalized. So we're going to normalize the result of 4, comma, 0, comma, 4. Normalize, open hard bracket, open parentheses, 4, comma, 0. These are just normal vector operations. You're dividing the vector by its length. Let's see what it does here. Hitting the equals button. And that's the result. That is the vector form of where your putt is going to break. So, remember again, the cross product of any two non-parallel vectors in a plane defines the normal. The cross product of the normal and the gravity, aka the down vector, defines the topo line direction. And then the cross product of the topo line and the normal defines down face. And it could sometimes be up face. It will be negative in the z if it's down face, won't it? So this is going to be up face when you look at it. The reverse is going to be down face if you're thinking about going down elevation for that. If you're not playing, of course, sky golf, it might go up. All right, so we'll be looking at sky golf and the as one of our conduits, with the expectation that we'll probably more likely be designing golf courses than sky golf courses. But those three things, Wolfram Alpha, we'll look at it, do it other ways. You've covered some of this mathematics already. You'll cover it again in your math class, but learning how to do cross products of vectors is one of these nice, beautiful, elegant solutions by hand, so we'll do that in class as well. Thanks for listening.